All right, welcome everyone. So tomorrow is our last test of the semester, and it will only consist of two main concepts. One is given a graph on a coordinate plane. We have to try to show if two sides are equal or if three sides are equal. So in other words, I'll start typing the topics. If it's isosceles, I think I'll put it in the middle. So show that a triangle is isosceles, equilateral, scalene, or scalene. Oh yeah. Another topic is show. Let me see. Oh yeah, show if a parallelogram is a rhombus, a rectangle, or square. Show. Let me see what else is there. The diagonals bisect each other. Show the sides of rectangle are perpendicular. In other words, the angles are 90. Okay, so let me answer the questions. Okay, so there were proofs from chapter 6 tests from last week, and we had to classify the parallelogram. So one of the questions, I think the one that Brooklyn is maybe talking about is the one that looked like this on the test. So this is one full segment. So if I put numbers like 1, 2, 3, 4, and if it's asking us, this is an old one, but if it's asking us A, B, C, D, E, F, G. So the two items are parallelograms, and C, E, F, G, so given. And let's say we wanted to prove angle A is congruent to angle F. So what we know about parallelograms, since A, B, C, D is a parallelogram, we know opposite angles are congruent. So number 2, we could say angle A is congruent to angle 2. And also in the bigger parallelogram, CEFG, we know 3 is congruent to F. So all of that information is due to the fact that opposite angles are congruent in a parallelogram. So you just want to state, in a parallelogram, that's one of the facts, one of the scenarios. So afterwards, it's not enough to, that alone is not enough to do the result. So we need to somehow share that 3 and 2 are congruent, and this is an old fact. That's vertical angles theorem. So vertical angles are congruent. In my class, we do VAT. So from there, notice that A and 2 are equal, and 2 and 3 are equal, and 3 and F are equal. So I'm going to look at the red, the yellow, and then the green. So this is basically transitive property. So the red ones and the yellow ones, basically the 2's cancel, right? Transitive property. And then the now the red A is congruent to the yellow 3. And if you look at that with the green one, that means the 3's will cancel. So it's either transitive property or substitution. So that was one from last week's test. All right. Substitution. There won't be like these 2-column proofs. It'll more so be, the showing, the justifying using math. So let me find the homework problems. Sydney, do you know what page those are from? I could probably guess what page it is, but I'm gonna assume this is page 410. Is that accurate, Sydney? 410? Okay. So Sydney asked about page 410, number 10 and 12. And I don't know about 42. Is that from the same page or is that from a different page? That might be from a different page. Well, it could be. Okay, I'll take a look in a little bit. Oh, okay, thank you, thank you. So from here, number 10. Oh, I lost my spot. 410. Okay. Number 10, there's extra information that you have to put in. So we have S, T, W, Z, S, T, W, Z, and it tells us it's a parallelogram. So what we can assume is that this horizontal distance is the same as this horizontal distance. And we could assume this vertical distance is the same as this vertical distance. So we can create right triangles outside the parallelogram and inside the parallelogram. Okay, just FYI, that's always a fact for parallelograms. So let me go back to what it gave us. It said capital S, so point S is A units from the origin. So capital S is A units from the origin. So here is length A, right here to here. That means I can figure out what coordinate S is right off the bat. And I did, so you're starting at the origin right here, this dot, and you're gonna go 0, because you didn't move left or right, and you're gonna go up A units. So that's end of story for that one. Then there's some extra information. It says capital Z, so point Z is B units from the origin. So the yellow portion is B units. So Z is pretty easy to find, this coordinate right here. And that coordinate right there, I went right B units. So this is B positive because I went right. And I didn't go up or down, so it has to be 0. So B comma 0. So those are done. Okay, then there's no information of how big or how, the distance from Z to W. So we have to make up a pretend letter. And we can't use A, we can't use B because we don't know. Since we don't know, we're going to call this gray amount just a new letter. It wasn't in the book. You just have to create a new letter. You could pick C, you could pick D, E, F, because it never told us. So from there, if I want to get all the way to W, you have to think of segment addition postulate. From origin to this point Z, I went B units. And from point Z to W, I went C units. So from start to finish, from here to here, W would be B plus C. That's how much I went right. And I didn't go up or down, so that's going to be 0. So there's my value for W. Lastly, for T, let's see. You know how this is a parallelogram? So we know this amount, which we colored in gray just earlier, right here. This amount is C units. So because it's a parallelogram, we know this amount up here has to be C units. Opposite sides are congruent. So if I'm trying to find the coordinate for T, let me redraw just T only. Then T is right here. So if you start from the origin, which is right here, I went C units, and then I went up A units. Therefore, my coordinate for T is C comma A. You could choose any letter, just don't choose A or B because that means you're assuming they're congruent, but we can't. So that's page 410, number 10. You had to add an extra letter, not A or B, into this problem, okay? So number 10 is somewhat tricky due to the fact you had to add an extra letter. I know in Tir's class, I added that into the notes worksheet since it wasn't written. So I just picked any letter and said we'll use that. So I see a few more questions, and I'm gonna try to answer number 12. So I did 10, 12, 40, 42, and I see 17, 18. This is on page 410 and 424. Okay, and let me just read a couple questions. Oh, gotcha, Brooklyn. Yes, I can definitely do that. If you can't make a variable, how do you use the A plus B equals C? It depends. Let me see, Via, if I can answer that question a little bit later. Okay, so let me do number 12 from page 410. And this one's an isosceles trapezoid. And it says it is centered at the origin, so it is symmetrical. Okay, so in other words, it didn't tell you this, but you could put tick marks here because it's in the center. We know it's isosceles, and then we could put tick marks up here, okay, because it told us it's centered. So S, T, W, Z. It gave us a couple lengths. It said the base is 2A. OR, oh, here's O. Oh, and this is R. OR is C units. So they told us that amount. That was given to us, C units. So what are we trying to find? What are the coordinates of the vertices? So we don't need to find R. That's not a vertice. We need to find T, W, Z, S. And it only gave us one base. Interesting. So I think number 12, we have to create another base. So I'm just going to pick the top as 2A, but we were not given another base length, so I'm just going to pick another one. So that's the bummer part. I'm just going to pick 2C or something like, oh, no, I can't do C. I already did C. Let's just do like 2B. So this was not given, okay? So I just created a new letter, not A or not C. Okay, so from here, let me see, oops. 5A from today's mini practice test. Yes, okay. So you have to think about this is the whole length. So you don't want to use 2A. That means just this portion from the y-axis to W is only 1A. And so let me just start off with that. So if I want to find coordinate W, it looks like I went A units to the right, and then I went C units up. So W would be A comma C. So always start at the origin and see how much did you go right and how much did you go up. And that's how we landed at A comma C. Okay, then you should deduce that T is the same thing except you went backwards, right? So if you went backwards, that means you're going to be negative A, and still up, that would represent, positive. So coordinate T would be negative A, comma, positive C. Okay. Then let's look at Z. So Z is, how do you is not SC. Oh, we don't. That's true, Brooklyn. That's a great question. We don't. So this answer could vary because it wasn't specific. It just said the base, one base is 2A. So this could be switched. So I could draw it out after. So thanks for that. That's a good notice. And 4C, yes, in the practice test. 4C, okay. So the bottom part, again, I just made it up. It's half of the whole thing, which would be 2B. So we could just create something. And then the bottom part would be also 1B. So this is even easier because you just went right, but you didn't go up or down. So it's going to be B0. If you're going left, you're going to be negative, and then you didn't go up or down. So Brooklyn had a really great point. She mentioned, how did I know this top is 2A, and then the bottom I made up 2B, versus it could have been 2A for the bottom, and then 2B for the top. It could. We don't know. It wasn't specific. So, let me see. Let me go back. Wouldn't S equal negative A? Right, Sydney. So if I changed it, right, then this would be negative B comma 0, and this would be B comma 0. This is A comma C and negative A comma C. But if I totally changed it, because I changed the top base to B, it would just switch the letters. BC or negative BC. Sorry, that looks like a 6. And then the bottom would be negative A0 and positive A0. And even, the test will be more specific. It will probably reference, it'll tell you, which base or whatnot, like the top base, or, and if it doesn't, then I'm pretty sure, like for me at least, it's flexible unless it says the shorter base, but if it doesn't say, like, all of these answers are legit. I could have even said the top is 2A and the bottom was just B. That would be a game changer. This will be half of B, right? And this will be negative half of B. Oops. So it really varies. So this answer could have a lot of variations. Yes, it should be specific. Yes, okay. All right, so then let me go on to 40 and then 42. I think it was Sydney that asked this earlier, but I'm assuming this is number, yes, it is page number 424. So let me go to 424. And number 40, and then I'll get to 42, 17, 18, and then the practice test. So number 40, they gave us coordinates. Okay, as I read it, I'm going to graph it. So G is 2, 5. So 1, 2, 3, 4, 5. So here's G. And then, oh man, I should have read it first. I got to go higher. So let me start all over, okay? All right. So there we go. So 2, 5. 1, 2, 3, 4, 5 is G. And then R is 5, 8. This is definitely not to scale, so sorry. That one is R. Then negative 2, 12. So this is 8. This is 5. 1, 2, 3, 4. 12. Right here, that is what? A. And then D is negative 5, 9. Okay, so I know my graph is not accurate because the grid is not too great, but here is my visual, my quick visual. If those who have graph paper, oh my gosh, if you use Desmos, that would be awesome, because Desmos is an online graphing calculator which will show you all the coordinates. So let me just log into my Desmos account really quick and see if I could plot them and get the numbers. So in the meantime, it says, what precise quadrilateral does this look like? So at the moment, in my opinion, it looks like a parallelogram. but that's because my drawing is a little out of scale. And if I had better graph paper, I would be able to tell a little bit better. But always graph it first, see what it looks like. I'm just using Desmos just to double check. So give me a moment. I'm using my phone, Desmos phone app that I have. It's really just easy to download. It's free. You could even use just web browser. You know, go to Chrome or Safari or Mozilla and then type in desmos.com. Let me see. So -5,9. Okay, so I graphed mine and it does look like a parallelogram according to a better grid from Desmos. Yeah. So cool. I didn't graph it too terribly. So GRAD, grad. How cute. So to actually show it's a parallelogram, you have options. The first thing comes in mind is the opposite sides are parallel. So that means I need to show that AD is parallel to RG. But how do you show parallel? You need to use slope. So in order to use slope, so I can't put those arrows right now. That's what I want to show because it looks like it's a parallelogram. So we need to find slope of AD and slope of RG, and you can use your formula. You can use rise over run. It looks like rise would be, let me see, D is 9, A is 12. So that's 3, rise 3. And then run is, let me see, D is -5 to -2. That means it is 3 units. So 3 over 3, which is basically 1. That's your slope. And I want to make sure RG is the same too. So I'm going to start at G. It's at 5. So R is 8. So yep, that's 3. 3 up. And then G is 2 to 5. So that's 3. Yay! So 3 over 3 is the same. So right now, we just proved by numbers that the opposite sides are parallel. Woohoo! So slope of 1, the same slope. So far, opposite sides are parallel. So to be more specific, AD is parallel to RG. I'm not done yet though. I need to make sure I prove the other longer sides are parallel. So I want to make sure these are parallel. They're not yet, but that's what I want to show in the future. So I got to do slope again. Sorry, it's getting kind of cluttered here. So slope of DG. So I'll start at D, and it doesn't matter. I'm going to go down. Let me see. D to G. D is 9. G is 5. So I went down 4. So -4. And then I ran. Let me see. Rise over run, right? So let's see. D is -5 and G is 2. So that's 7 units. So I have -4 over 7. That's the slope. And the slope of AR, I hope is the same. Some of you might have already done it. So AR, A is 12, D is 9. I'm sorry, R is 8. So that's 4 units down. So -4, woohoo, looking promising. And then A, I'm looking at the X coordinates to R. So -2 to 5 is 7. Yay! So we did it again. We showed they have the same slope, which means opposite sides are parallel. And we say DG is parallel to AR. So we want to say, if you had to write a concluding sentence, for instance, tomorrow. So if you had to write a conclusion, something along the lines of this, you would say the opposite sides are parallel because the slopes of the opposite sides are the same. Ta-da! And you could be more specific. You could incorporate, the letters. So you can say, I already forgot the letters. What was it? G, D, and AR. So you could say GD is parallel to AR. I don't have the segment bar. And then you can say GA is parallel to DR. Is that? Let me just double check. GADR. Nope, that's wrong. ADRG. That is wrong. That is wrong. And AD is parallel to RG. Oh, my other conclusion got erased. Slopes are opposite sides are parallel. Okay, ta-da! All right, so number 40 was that. Number 42, you're right, it is similar. So what you would do is you would graph it, best of your ability, and then you would first say, ooh, this looks like, in your opinion, like this looks like something. 42 ends up being a rhombus. And for rhombus, yes, you could too. You could find distances too. Absolutely, Matt. And V, yeah, you're right. So both of you, I could have done it a totally different way. I could have found the distance, Pythagorean theorem, if you like that instead. That's what Tirotera's class focuses more on than distance formula. Find the distance of AD, find the distance of RG, they should be the same. Find the distance of AR, find the distance of GD, they should be the same. So you could either do slope or you can do side, length, so distance, and you'll get the same results. Cool. But let me just once again say for 42, the answer is rhombus. You do want to graph it, okay? So you want to graph it, and you first kind of guess what it looks like in your opinion. But in this case, you have to show all sides are equal. So you want to find all four sides, and they should equal to the same number. I forget what number they all ended up being. I could find one of them just to kind of make sure. I'm not going to do all of 42 if that's okay. But like let's say you have 4, 5, that's Q, and then 12, 14 all the way up here. That is U, and then 25, here is A, and then 12, -4. Somewhere around here. So this is just like a quick sketch quad. Now, because my quick sketch is not the greatest, let's say you find AD. So to find AD, I'm just going to write the coordinates, 20, 5, and then D is 12, -4. So Tirotera's class, what we did was we found what's this horizontal distance. So between 12 and 20, that's 8 units. If you don't like that, you can definitely do 20 minus 12 squared, but you'll end up getting the same. And then Tirotera's class, we made this a right triangle, so we're using like Pythagorean theorem. We're like, ooh, what's the vertical distance between 5 and -4? That's 9 units. But if you're not familiar with that, you can do distance formula, 5 minus -4, which turns into positive, and you'll end up getting the same thing. These are the same. So 64 plus 81, that is a big number. 64, 81, 145, I believe. So it seems like AD is square root of 145, and that means all the other sides have to be 145. So you want to show each segment, AD, QD, UQ, and UA. You want to show every single one of those are square root of 145, square root of 145. Okay, that's 42. I know I didn't do the whole entire thing, but you want to try to find distance for all of them. If it asks a concluding sentence, so you would say quad is a rhombus because all sides are equal / congruent using distance formula or Pythagorean theorem. So something along those lines I think is sufficient. You could be specific. You can show like, hey, I did all my math work, and you can say QU is equal or congruent to UA, and that's congruent to AD, and that's congruent to DQ. So I'm not sure how every teacher does it, and how specific every teacher would like it, but I think that's pretty good right here, these just justifying your math in words. Okay, now it says 17 and 18, so I don't know if Kyle is still here. I don't know what number, or what page that is. I'm thinking it's the 410. Let me just slide back 410, see if Kyle is still here. 17 and 18. Page 4, 24, 17, and 18. I mean, I don't see why not. You could ask Mrs. Bratcher right before the test, like right when you get to her classroom. It just, oh, it's 410. It's really the same thing, and you're going to learn it next semester, and I just feel like it ties in really nicely, so that's why I did it with my class. But yeah, I don't know. I guess I wish I could say yes, but I really don't know, so sorry, I can't answer that, Sarah. All right, so number 17, plus on page 410. This is an isosceles trapezoid. That's what it told us. Okay, and Brooklyn, I still have to answer your question. I remembered. Okay, I will get to that one. So I have O for the origin. What does it want? It wants P. Oh, okay. So here is AB. This might answer V's question from earlier with the A plus B kind of stuff. And here is C, comma 0. So the horizontal distance from these two red parts, that horizontal distance is, oh, that's too far out, is A units right here, okay? Well, since this is an isosceles triangle, I could create right triangles within it. So that forces this also to be A, by the way, okay? Also, the whole bottom base, it is C units, okay? So if I'm trying to figure out this distance, because I'm trying to go from here, to here, I'm trying to figure out this distance, then we have to subtract, it looks like, right? Now, if you use numbers, it would be so much easier. So let me like incorporate numbers instead of letters if it's kind of weird and mixed up. So let's say this coordinate right here was 7, 0. And let's say this up here was 2, 4. So that means this distance is 2, this distance is 2, and if we're trying to figure, well, we know this distance is 7, and trying to figure out what it is from up to here, that would be 7 minus the yellow 2. This will be 5. All right, so left over, there's a gap right here. So it's 7 minus 2, so 5. So it's the same idea. If you look at the top picture, we're trying to figure out this green distance, and that green distance will be the leftover of from C minus the red A. So what I'm trying to get is right here. This I want to know what this coordinate is. I need to know what that coordinate P is. So therefore my horizontal distance from the origin, right? The origin to that point P is C minus A. And then I went up the same amount as I did over here, which will be B. So final answer is C minus A, comma, B for number 17 on page 411. Number 18 on the same page. So this is the final answer. So hopefully the number one on the bottom was just like an example, but hopefully that kind of helped give the picture a little bit more oomph. Okay, number 18, page 410 or page 411. It is a trapezoid with a right angle. Okay, so here, we have the origin, 0, 0. This is 0, C. Up here. Looks like the right angle is down here because it's, yeah, it's right on the X and Y axis, so that has to be right angle. The slopes are opposite reciprocals, perpendicular. Okay, so what are we trying to find? Oh, this one, this coordinate right here. Right here, we don't need to go up anywhere. We're just trying to figure out the horizontal distance. And wouldn't you say it's the same as up here? So if that's the case, then we're going to just copy and paste that. It's the same horizontal distance. So you went right A units, and you didn't go up or down. So that will be A comma 0. That one's a lot faster for compared to 17. Yeah, that was pretty good. Okay, then I think the next questions are the practice test, and then the one from chapter 6, the old test, those trickier questions. So let me find my practice test. Let's see, what's the homework? There it is. So 5A. So, okay, so I hope this is the same practice test as whoever asked earlier. Practice test. All right. It says show or graph ABCD. And then it says show using math. It's a parallelogram. And earlier, I think we did this. This was like number 40 from the textbook. It's like number 40 from the textbook. And I gave like a hint. It says use slope. So you want to show opposite sides are parallel. So I'm going to graph it. Let me see. It's -6, 3. So that's coordinate A. Then -2, 0. That's B. -2, -5. That's C. And then -6, 2, -2. This is D. So let's connect A, B, C, D. Whoa. All right, so if we're trying to show it's a parallelogram, we have a lot of options. Option 1, you can show AB is parallel to DC, and you can show AD is parallel to BC. Option 2, you can show opposite sides are congruent. So another option is show that they're congruent instead of parallel. Okay, so I'm going to do this one, okay, because that's really the definition of parallelogram, is to show opposite sides are parallel. So in order to show that they're parallel, I must show that the slopes are equal. So I have to find slope of AB and the slope of DC. And it's rise over run. You can use the coordinates if you're really comfortable subtracting the y's over subtracting the x's. Or I just like counting, you know. So AB, I'm at positive 3, and I went down 3 units, so that's negative 3. Then I went 1, 2, 3, 4 units, so there's my slope, negative 3/4. Do it again for DC, so I went down, is that 3 units? I hope so, 3 units. And then I went over 1, 2, 3, 4, 5, wait, 1, 2, 3, 4 units. So negative 3/4. Again, so that's good. We want it to be the same. So since they're the same slope, that means the sides, opposite sides are parallel. So far, so good. And then you do it again for AD and BC. Anyone know what kind of slope vertical segment or vertical line is? What kind of slope? It's not 0. What kind of slope is AD and BC? You could count it too. You'll get some weird, funky answer. You got it, guys. So it is 0. I mean, undefined. Let me count it. AD. It went 5, like up or down, depending on where you start, over 0. And BC also went 5 over 0. But they're both, the answers are undefined, just like 4 people wrote down. So undefined, undefined. Cool. Since they're the same, boom, opposite sides are parallel. So same slope. Okay. All right. Number 4C on the practice. And that's right above it. So there was already a graph for you, and it was triangle XYZ. And I'm just going to do a rough sketch. X, Y, Z. And appearance-wise, it looks like Y is the right angle right here. It looks like it. So it says use math and words if angle Y is a right angle. So we don't know for sure. Oh yeah, good. Thank you guys for answering. So if we're trying to show angle Y is a right angle or not, we have to show that it's perpendicular, that XY is perpendicular to YZ. That's the goal. We need to show that. In order to show that, we need to find what? What do we have to find? Anyone can answer. To show if they're perpendicular. What about the slope? What do we have to show the slopes are? Yes, they're perpendicular. And how do you notice if they are perpendicular? What numbers will we get? Opposite and something else. Yes, you guys got it. So let's do the math, right? So x, y, oh, I just labeled it wrong. Okay, so this is x. So x, y, it looks like, I know there's no grid on mine, but I see mine paper. I'm going to count. It went from x, it went down 1, 2, 3, 4. So negative 4. And then backwards, negative 2. So that ends up simplifying to just positive 2. That's good news because this green segment is rising. So it has to be a positive slope. And it looks like slope man. So if it is a rising eyebrow, his slope will be positive. If it's a declining eyebrow, it's a negative slope. If the nose is flat, like up and down, it's undefined. And if your mustache or whatnot mouth is side to side, then it's 0. So that's your slope man. Okay, and then YZ, this other green segment, I know you don't have a grid here in front of you, but it went down 2 units. So that's -2. And then it went to the side. So it went to the right 4 units. So if you simplify -2 over 4, that is -1/2. And these two numbers are opposite signs. One's positive, one's negative, and they are reciprocals. 2 over 1 is a reciprocal of 1 over 2. So that works out. Yeah. And we know that when you multiply them, when you multiply the two slopes, you will get -1. So Andrew and Ellie, yes, nice job. So if you multiply the slopes, you will get -1. Okay? How can you tell that something is undefined? Something is undefined whenever it is a vertical segment. So if I have, for instance, 4, 0, 4, 8, and 4, 2 or something. So if you did do slope, y2 minus y1, x2 minus x1, subtract the y's, 8 minus 2, subtract the x's, 4 minus 4, and we end up getting 6 over 0. Whenever you have 0 on the bottom, it is always undefined. When you put in your calculator, it'll say error, or like, I don't know, undefined. I don't think it says undefined, but it always says some kind of like syntax error or something. So you can tell by that. What else is there? I think that's about it for undefined. Yeah. So whenever you're dividing by 0, it's undefined, or graphically, if it's a vertical segment or line, it's undefined. Slope. Okay, this is a slope. All right. Yeah, number 14 on the practice test. Let's see. So it says rectangle. Okay. So you want to graph it, and there were points 0, 0. I'll call that A. And then 0, N. I'll call that B. And M0. I guess I'll call that C. And then MN, I'll call that D. So this is rectangle. If you go in order, this is rectangle A, B, D, C. A, B, D, C. Okay, or A, C, D, B. Anyway, it says show by using math the diagonals bisect. So we know in rectangles, the diagonals are congruent. And for it to bisect, that means they have the same midpoint. So diagonals bisect means they have the same midpoint. And that means we have to physically find the midpoint of AD. And let's do it right now. So to find the midpoint of AD, well, the midpoint formula, you just take the x's, divide by 2, and take the y's, divide by 2. So let's take the x's. The x's is m and 0, so I'm going to add those two up, divide by 2. And then you're going to take your y's, 0 and n, and divide by 2. So my answer is m over 2, n over 2. That's the midpoint, okay, of AD. And I do it all over again, but I have to do it for BC. So for BC, I'm going to take 0 and m, so 0 plus m over 2, and n and 0 divided by 2. Woo, this is looking good because it is the same exact coordinate. They're both m over 2, n over 2, which means they have the same midpoint. And if they have the same midpoint, that means, these two, like on the left side of the midpoint and the right side of the midpoint, it's the same amount. And same for the other segment. So that's how it bisects each other, because it creates congruent parts, congruent two parts. Page 45 on 424, and then let me kind of pause and after that and answer the questions from last chapter test. Number 45, because those were interesting. 424, let me turn to, okay, I'm already there. Number 45. So the figure at the right, it's a parallelogram, and we need to find coordinate P. Got it, okay. So here, and it's the origin, negative A0, and negative BC. So we're trying to find coordinate P. What's this coordinate right here? All right, so step one, this whole green length should be the same as this whole green length. Distance-wise, no negatives. This is A units, so this whole thing is A units. Okay, that's just based off of it, because it told us it's a parallelogram. It did. So, okay. Then, let me see, another color, here we go. But if I wanted to get to this point, it looks like this here alone is B units. So from start to finish, right here is B units. That means if I want to figure out the leftover, which is going to be right here, that is the green minus the red. So if I want to figure out how much I went this way, this leftover, that's A minus B. So this amount is A minus B units. The green minus the red. So A minus B is your X value, and you have to figure out how much you went up. Well, I went up the same amount as I did over here, and that will be C. So that, exactly. So that will be your, I guess, final result. So what I suggest is, always start at the origin and see, okay, from origin to this bullet point, right? These 2 points, here's your distance, A units. So that's how I labeled the green one. And then on the top part, it's the same exact thing. So I labeled the whole thing as A. And then starting at, not really the origin, but starting at the y-axis to this point right here, that has to be B units. So, try to do segment addition postulate where you have B, you have A, and you're trying to find the leftover. If you don't understand with letters, use numbers. Just pretend, A is 10. Pretend B is 2. So what's the leftover? You're like, oh yeah, 8. Like you could do that in your head, but you have to think, how did I get 8? I did 10 minus 2. And then you're like, oh, now I can rewrite it and say this is A minus B. Okay? So Gina, I'll do 40 in a little bit, but let me talk about the 4 problems from the last test, just because they're really good thinker ones. I don't have it in front of me, but I remember for the most part what it was. So we had this picture on the last test, and it suggested that these 2 marked angles, are complementary, which means they add to 90, those 2. So what we had to look at was this green triangle. And in any triangle, no matter what, they always add to 180. So that means I've already used up 90. This leftover angle has to be what? What's the leftover? Has to be some number, right? 90 plus something. It has to be 90. So you're like, oh. And then, vertical angles and then linear pairs. So they're all 90s in the middle. Well, then what shape out of your parallelograms have 90s in the middle? And that answer is rhombus. Okay. Another question, very similar to that one, this was from the last test, was you have parallelogram for sure. it said this entire angle, this entire combined angle, and oh shoot, I don't think it was that one. It was this other angle. This entire angle, not entire, but this portion, this red portion, plus this portion ended up being complementary again, meaning 90 degrees. It adds to 90. So it could be like 60-30. It could be 75-15. It could be 10-80. Like we don't know, but we don't even care. We don't need that information. We just had to figure out, what is this leftover angle, this yellow triangle, and that leftover angle has to be 90, which forces the opposing angle to be 90. And you're like, oh man, all of the angles have to be 90, 90, 90. Well, then now, if you redraw it, 90, 90, 90, it will be a rectangle for that one. So those were the most missed questions, by the way, from last test. There was one other one. It said, just based off the information, it said these two are congruent. These two are congruent. So they share the same midpoint, but all it is was this was just a parallelogram. It wasn't any special thing. And how do we get a square? I think this was what it was. So here it is. So it suggested that these two parts are congruent, and it also suggested something along the lines, these two. So now you had to use your parallelogram facts. And the parallelogram fact says opposite sides are congruent. Parallelogram fact says opposite sides are congruent. Oh man, all the sides have one tick mark. So far it's a rhombus. Okay, but in addition to that, we know diagonals bisect each other. So this diagonal, this long diagonal, one of them has one tick mark. You could put one more tick mark. And then the shorter diagonal, this one, ooh, it already has one tick mark. So that has one tick mark. So then from there, the diagonals bisect each other. In addition, because that's parallelogram, right? In addition, the diagonals are congruent. Oh, what? So it could be a square. So all sides are equal, and the diagonals are congruent, which forces this to be a good old square. I should put different tick marks, sorry. That doesn't make sense. There we go. Okay, so final answer is square for that one. Okay. All right, I think 40, I think we did 40 earlier, so definitely I'll put the link up and you can rewatch it, but 40, I'll just kind of re-explain. You had to graph it, and it ended up being, like, once you graph it very accurately, it ended up looking like a parallelogram. So it ended up looking something like this. And it still says you have to, I know it didn't say in the book, but the expectation from, I think, all your teachers, all your classes, is you have to justify it using math. So yes, we can all kind of see and it looks like a parallelogram, but to justify it, you had to show that the opposite sides are actually parallel or congruent. I went the parallel route earlier, so I found the slope of this segment, the slope of this segment, and they were the same. So you had to find the slope, and they were the same. And so that forces them to be parallel. And then you do the same thing for the other opposing sides, opposite sides. You find the slope, and then they were the same too. So they're parallel. So let me recap a little bit before we end our session. And I see a few questions. Yes, that is a very great conclusion. So for number 40, The opposite sides are parallel because the slopes of the opposite sides are the same. That is well said. So summary, if you're trying to show if it's a parallelogram, you want to show opposite sides are parallel, just like Sydney said. I'm going to take her words. And that's because the slopes are, yes, it could, but for a rectangle, you also have to show the angles are 90. That's one extra step. So I'll get there. So parallelogram, opposite sides are parallel, so slopes are the same. Slopes of opposite sides are the same. If you're trying to show it's a rectangle, then you need to show that the adjacent or consecutive sides are perpendicular. That's a different story, meaning the slopes of the adjacent consecutive sides are opposite reciprocal. Sorry, opposite reciprocal. So for instance, 1/2 and -2, or 2/3 and -3/2, or -5 and 1/5. If you're trying to show it's a rhombus, then you need to show all sides are equal. And in order to do that, you have to show the distance. And most of the times, they're rad answers, right? Sometimes they're whole numbers. For instance, if you have a segment that's horizontal, oh my gosh, just count it. Like 1, 2, 3, right? Count it, and that's just done. That's 3 units. But if you have a segment that's diagonal, then you have to have a rad answer. Unless it's like rad 25, then it's whole number 5. You know, if you have a vertical segment, oh, that's nice. You could just count 1, 2. You know, so if you have a diagonal, again, you will have to use Pythagorean theorem or distance formula. Okay, what other shapes are there? We did rectangle, we did rhombus. Square, you would have to do both, right? Square, you would have to show sides are equal and sides, the adjacent sides are perpendicular. So opposite reciprocal slopes. So m equals 2/3 and m equals -3/2. Those are opposite reciprocals. And sides would be like rad 3, rad 3, rad 3, rad 3, you know, all the same. 10 and 12. Oh, we just did that, Alec. 10 and 12. So I will stop the recording pretty soon, and then I'll just put the link up. But number 10, I just want to kind of give you a quick breakdown for 10. You have to use a new letter, Alec. You have to add a letter. So it only gave you a few things. So it only gave you that this amount is B units and this amount is A. That's all it gave us. So you had to make up a value for ZW, and I personally picked C. And then Tuesday's homework, yeah. So then for finding the coordinates, I think the hardest one is, no, not the hardest one, but the weird ones are T and W. So W is a combination of the two reds. So that would be red plus yellow. And that's your answer. T would be whatever this length is. What's the same length as the bottom? Because it's a parallelogram. So it's just C units. And then we went up A units. S is easier than the other two. That one is you didn't go up or down. I mean, you didn't, yeah, you didn't, oh no, you didn't go left or right. So 0, but you went up A units. And then Z, that one is from the origin. You went B units and you didn't go anywhere. Number 12, that one, you have to make up, I'm not going to finish it because I just did that one earlier, but you can rewatch the recording in a little bit. This one, it only gave you one base, so I just assigned the top to be 2A, and this bottom, I made it up, I just made it 2B. And the height here is C. So you have to find those 4 coordinates for number 12, okay? And then Tuesday's homework, yeah, let me see. Tuesday was 6-8. Read number 10. I think, is that on the back? Oh, yeah. I will send a blank practice test over to the GVL GVL Remind, so you can get a glimpse of it. What is the question mark? Why do the practice test and review? It's the same thing. Question mark FR. I don't know what you're asking, Matt. Okay, so this was one last question I'll do. This is number 10 from Tuesday's homework, 6-8. I'm going to stop the recording